In this video, we're going to take a look at reverse engineering a part inside of SolidWorks using Artec Studio 16. So we have our part here on screen. It's made up of prismatic geometry as well as some more freeform organic geometry. And this object was reverse engineered entirely using Artec Studio 16. We're going to walk you through that process here today. Artec Studio allows us to create a lot of different geometry that can aid in reverse engineering, such as freeform surfaces like we have on this part, primitives that we can use for either reference information or to aid in alignment, as well as bullioning to create really nice, clean geometry on our parts, as well as the ability to create 2D profiles that we can sketch off of and extrude either as bosses or cuts inside of SolidWorks. So today we will primarily focus on using the 2D profiles and the freeform surfaces for the reverse engineering, as well as show how we can create primitives for our alignment process and what they can be used for. So to start off with on our part, we'll go ahead and talk about how we can create this geometry inside of Artec Studio 16. We have our Construct tab that will allow us to create primitives such as planes, cylinders, and freeform surfaces, which are all present on this part. To be able to create this geometry from our scan file is really simple. We simply select the area that we want to create as a primitive. For instance, here we'll go ahead and grab a cylinder. We can use a variety of tools, such as our segment tool that allows us to, with one click, capture all of the information of that cylinder and then best fit through that surface, as well as we can create a plane and do the same process to very easily build out that plane. Additionally, we can add in constraints to our parts now, which is really beneficial for being able to have very precise data that is all constrained around a series of primitives. So, for instance, here we have a perpendicular constraint between those two parts. And if we wanted concentricity, or if we wanted to treat a particular area of our part as our reference and then make sure the rest of the primitives are built around that, we can do that very easily. Additionally, we've gone in and created a few 2D profiles using those primitives that will take over into SolidWorks and begin constructing our part off of. So to use these 2D profiles, we can simply bring all of this information into a SolidWorks assembly file and then go ahead and create a new part that will be our object. So we'll go ahead and create a new part and reference it off of one of these 2D profiles. And with the way that we export the data from Artec Studio, we can export this out as either DXF information or a step file. And with the step files, it makes it very simple for us to either sketch lines, arcs, splines, circles, whatever geometry that you need by simply finding the data points that you want to build your part off of, selecting those data points, and then sketching out your geometry. And once we've finished sketching out the external geometry of the part, we can very quickly and easily trim everything together and extrude it out as one solid body. Now that we have our 2D profile, we can also go ahead and use our freeform surface that we created in Artec Studio 16 to be able to extrude that 2D profile up into a solid object that has a freeform surface on the top, making it very simple and easy to work with complex organic shapes with really just the click of a button. Now that we have the basic solid object, we have some internal geometry that we need to cut away. So to cut away this internal geometry, it's mainly revolved around one central axis. And for this video, we will be simply creating the 2D sketch around the perimeter of our part and then revolving that away as a cut. There are a variety of different ways that we can achieve this goal. We could import the primitives from Artec Studio and use those to cut away the geometry, or we can just accomplish the same task with one large revolved surface. This is where our constraints inside of Artec Studio can be really important because it makes it very easy for us to find the center axis of our part and be assured that we are accurately revolving this information around that center point. Because we already have really good geometry here on this part, we'll simply just create a center line based off of the midpoint of our internal cylinders and use that for our revolved surface. So we'll again sketch everything out, trim everything together, get rid of any of the excess sketch lines that we don't need, and finish this part off by revolving out this cut. Additionally, if we need to make any modifications to our part, we can simply use our Smart Dimension tool to be able to Smart Dimension out anything that we need. And we'll finish this off by doing a revolved cut here on our object. And with that, we have gone ahead and created the main portions of our part here inside of SolidWorks. So we'll go ahead and just add a few finishing details here. We'll generate a fillet on this external edge to just clean that up a little bit. And with that, we have our basic object here reverse engineered inside of SolidWorks using Artec Studio 16.